Hello, good day everyone. Today we're gonna explore the addressing modes in the assembly language, specifically focusing on the 8086 architecture. We'll break down each exercise from our recent assignment to understand how different addressing modes work in practice. So, exercise 1. And in exercise 1, we identified the addressing mode for each instructions. Here's our some little breakdown. 1. Move AX BX. It is a register addressing mode. Number 2. Move AX 1234H is a direct addressing mode. Move ALCI register indirect addressing mode. Number 4. Move BP plus DIAX addressing mode base indexing addresses mode. This mode combines a base register BP and an index register DI to calculate the effective addresses. It's useful for addressing arrays or structures in memory where BP might point the start of the structure and the DI points to offset within it. So let's go back. In 1, the move AX and BX is a register addressing mode. This mode uses register directly, both AX and BX are registered, so the operation is performed entirely within the CPU without accessing memory. 2 is the addressing mode, direct addressing mode. This instruction specifies a fixed memory address 123H. The CPU fetches the value stored in the address and moves it into AX. This mode is straightforward but lacks flexibility since the address is hard-coded. The addressing mode, register indirect addressing mode, it is the address from which to fetch data is contained, or it is the container in the SI register. This allowed for dynamic memory access as the content of SI change. And the number 4, the base indexing addressing mode. This move combines a base register and DI, like what I said before. It is used for addressing arrays or structure in memory where BP might point at the start structure and DI points to an offset within it. The number 5, move CX BX SI08H, similar to the previous mode but includes an additional constant displacement. This allows for more complex addressing scenarios such as accessing elements in the array with an offset. Number 6, move DIAX BP10H. Move DIAX. The number 6. The DI register is used to determine the memory address where the value in AX should be stored. This mode is efficient for iterating through arrays. 7. The base index with displacement mode. This mode uses BP register with a negative offset, allowing access to data locations data located before the address point to the BP by the BP. It's particularly useful for stack operations. Number 8, move 8x 5678H immediate addressing mode. The instruction directly specified the value to the loaded in AX. This mode is efficient for loading constants but is limited to values that can fit within instructions. And last, the number 9, move AX BX. Register indirect addressing mode. Similar to the earlier example with SI, but here, the address is stored in the BX register, which allows to flexible data access based in the current value in BX. Number 2, write code for specific address mode. Write a sample code snippets to demonstrate the following addressing nodes. This exercise involved in writing code snippets, right? And number 1, immediate addressing. Store the values 0x55AA in the AX register. Move AX55AAH. The immediate value 55AAH is directly into the register. This is quick operation system memory access in required. Number 2, register addressing. Copy the contents of BX into AX. Move AX BX. The contents of the registered are copied in AX to this operation is passed as it is only involves register to register transfer. Move direct addressing. Move the store value memory location into AX. Move AX 1234 H. The value at the memory address 123H is fetched and placed into AX. This involves accessing memory which is slower than register access. Number 4, register indirect addressing. And access the memory location pointed to by SI and store in value in AX. Number 5, index addressing. Retrieve a value from memory address pointed by sum and displacement of 10H and store it in AL. The effective address is calculated by 10H to value in DI. This is useful for accessing elements in array where DI points to base the address. Number 6, base index addressing. Combines the value BX and then SI to compute the address. This is particularly useful for accessing multi-dimensional arrays. And the number 3, address calculations. In this exercise, we computed physical addresses based on the segment and offset values. Here detailed explanation. 1. Compute physical address to the instruction move AX 100H in direct addressing mode. Physical address seg reg x displacement plus offset. And the segment is multiplied by 16 to shift it left by 4 bits, effectively converting it to the byte address. The offset is then added to the value to get the final physical address, which is the 2100H. Alright. Number 2, compute the physical address to move AX, BX plus SI plus 10H. This shows multiple register and displacement can be combined to compute the effective address. So the final physical address is calculated similarly by converting the segment to a byte address and adding the computed offset, which is the 25565H. Right? Next. 4. Debug and analyze. In this exercise, we analyze code snippet and identify the addressing mode. Use. Analyze the code snippet and identify each mode used in each instructions. 1 is the move AXSI register in direct addressing mode. The data is accessed indirectly through the SI register. And the next, SI200H immediate addressing mode. And The SI register is loaded with an immediate value. AX SI plus 10H index addressing mode. The effective address is calculated by adding 10H to the value in SI, allowing access to the data at the locations. Move the AX register in direct addressing mode. The value in AX is stored at the address point 2 by DI. And 2. If the value at the memory location 200H is 123H and at 2000H plus 10H is 5678H, what will be the final value of AX? Initially, move AX SI loads the value from the address in SI. Move SI sets SI to 123. Move SI to H sets SI to 2000H. Add AX SI plus 10H as the value at the address of 200H plus 10H, which is 5670H to AX. Final calculation: AX equals to 123H plus 567H plus 68 equals to 68 ACH. Explanation: this demonstrates how data manipulate through various addressing modes, leading to the final result. Next, exercise 5. In this exercise, we wrote a small assembly program to demonstrate the use of different addressing modes. 1. Loads the value 0xABCD into the memory location 300H. Move AX ABCD. H move 3000H AX. This immediate value ABCDH is loaded in AX, and this value is stored at the memory location 300H. This operation involves both immediate and direct address. So next, retrieve this value using direct addressing mode and store it in AX. So gonna write move AX 3000H. The value stored at the memory location 3000H is loaded in AX. This is a direct access to the memory. Simple as that. You're gonna input the move AX 3000 so that it will directly address into the memory. So 3. Copies the value AX to BX using register addressing mode. So we gonna write move BX AX so that this operation copies the value from AX to BX, demonstrating register addressing. Or store the value in BX at the memory location pointed by the DI using register addressing mode. Move DI 400H, move DI BX. The DI register is the 400H and the value in BX is stored at the memory location pointed to by DI. This shows how register and direct addressing can be used to dynamically store values in memory. So, we're gonna see the whole assembly language program. Move AX, ABCDH, move 300H AX, move AX 300H, move BX H AX, move DI 400H, move DI BS. So the understanding addressing modes is fundamental for effective assembly language program. Each mode serves as a specific purpose and allow for different methods of accessing data, whether that be directly from memory, through register, or using complex calculation involving multiple register and displacements. By mastering this concept, programmers can write more efficient and flexible assembly code tailored to their specific applications. So that's all. Thank you for listening.